Hello student, in last video we were discussing about the basics of titration. In this lecture we will discuss types of titrations. There are how many types of titrations? There are basically four types of titrations commonly studied in the laboratories. Number one is acid base titration, second one is redox titration, third one is precipitation titration, and fourth one is complexometric titration. They are further classified into subtitles. For example, acid base titration have a next four types of titration: strong acid strong base titration, weak acid strong base titration, strong acid weak base, weak acid and weak acid and weak base titration. In the case of redox titration, there are five further types of redox titration: iodometry or iodometry, bromotometry, serimetry, magnetometry, and dichrometry. In precipitation titration, there are three types of titrations: Moore's method, Woolard methods, and Fudgens method. In complexometric titration, back titration, replacement titration, direct titration, and indirect titration. We will discuss all these step by step. In this lecture, we focused on only acid-base titrations. In the acid-base titration, amongst the four titration, for example, there is the strong acid and strong base titration. What is the example of strong acid? Is HCl, and example of strong base NaOH. For example, if titration is carried out between the HCl and NaOH, in which one is act as an analyte, other one is act as a titrant. Basically, that is a neutralization titration, acid-base titration, in which salt and water is produced. Its equivalent point is equal to 7. We know that for the titration purpose, suitable indicators are required. Suitable indicator for strong acid and strong base is phenolphthalein or methyl orange or bromothymol blue. Mostly we use phenolphthalein, strong acid and strong base titration in the laboratories. That's also suitable. Phenolphthalein is colorless to pink. In the case of phenolphthalein, pink color is appeared, but always keep in mind phenolphthalein is colorless. Weak acid is colorless in acidic solution but show color in the basic solution. And methyl orange, red to yellow, and bromothymol blue is yellow to blue. This is the case when we take the acid we take the acid in titration flask and strong base in the burettes. Then phenolphthalein give colorless to pink, because in an acidic solution it is colorless. When we add up the base from the burettes dropwise, after the at the point of end point, colorless suddenly change into pink color. And next is the weak acid or strong base. Weak acid is, for example, acetic acid, strong base NaOH. If we take the titration between strong acid and weak base, the pH is greater than 7 at the equivalent point. So on the basis of strong base, we choose the indicator, that's the phenolphthalein. It is also show the colorless to pink. And strong acid to weak base, HCl is the strong acid, for example ammonia is the strong weak base. If titration is carried out between the strong acid and weak base, its equivalent point pH is less than 7. In other words, the acidic, the most suitable indicator for this titration is methyl red or methyl orange. Methyl red give yellow to red, and methyl orange yellow to red. Okay. Next, weak acid and weak base. Ammonia is the weak base and acetic acid is the weak acid. If titration is carried out between these two acid and base, its end point where is depending upon the relative strength of weak acid and weak base. Its indicator is not more suitable. No sharp distinct color changes appeared in the case of weak acid and weak base. Now, what is the end point and equivalent point and end point? End point basically is the point where added volume of titrant is chemically equivalent to the amount of analyte present in the sample based on the reaction stoichiometry. This is the theoretical point. It is that theoretical point at which amount of in the other words, the number of moles of acers become equal to the number of moles of base in which complete neutralization reaction is carried out. No extra one molecule, extra one drop is added in the titration flask. Before the end point, this point appeared before the end point, but we cannot measure practically, so that this is known as theoretical point. We suppose that before the end point, equivalent point is appeared. First equivalent point is appeared, then in end point. End point is point at which indicator change color. It is signaling of visual completion of titrations. We can visualize. This is the indicator. It is the signal which show that stop the titration. At the point of titration, we stop the titration. We show that one extra amount, one extra drop of acid and base change the color. So reaction have been completed. That is the experimental completion, experimental change. So end point is the experimental point, but equivalent point is the theoretical point. It is the major difference between the acid end point and equivalent point. Okay, these are the some indicators are used basically in acid base titration. Red cabbage water, also use red onion water, turmeric acid, phenolphthalein, but we will talk about those indicators which commonly used in the laboratories: phenolphthalein, thymol blue, and sometimes universal indicators are used. Phenolphthalein mostly is colorless, is in acidic media, and colorless at point of 7, pH of 7, but pink color at pH greater than 7. And in a basic media it show the color. And bromothymal blue, basically it is yellow in less than 7, basic media, and green at pH is 7 and show the blue color in greater than 7, and the basic media show the blue color. Red litmus and blue litmus, these were used in laboratories, but nowadays these red litmus and blue litmus are not commonly used. Okay, hope so you understand all the concept related to the acid base indicator. Thank you very much.